Hi, I'm Brian with FlashCut CNC. In this video I'm going to talk to you about the 2.5 amp Compact Series microstepping controller. Then I'll show you a little bit about how to get it set up and running with your machine. Since 1996, FlashCut has provided tens of thousands of customers with affordable yet powerful turnkey CNC solutions. FlashCut is the only CNC solution that offers a dedicated controller with a high-speed USB connection that ensures smooth, uninterrupted motion in a multitasking Windows environment. The first thing I'm going to show you a little bit about is the controller itself. As with all the FlashCut controllers, we have 8 outputs, 8 inputs, as well as a dry contact relay output. These different inputs and outputs can be used with different accessories that you might have, and I'll go into depth a little bit more about the accessories that we offer with the FlashCut program. We also have a high-speed USB connection, and that ensures proper communication between the computer and the controller itself. And finally, we have the 30-volt power input, and this not only powers the signal generator, but as well as the drives that power your motors. Now I'm going to talk a little bit about the capabilities of the Compact Series. As you can see here, I have a couple motors laid out. Basically, the Compact Series can control any of these motors with ease. We've got the NEMA 17 motors all the way up to the 400 ounce NEMA 23 motors. I have a couple of these motors installed on this machine here. This machine is just for demonstration purposes. It's a good example of the kind of uses that the Compact Series was designed for. This is the FlashCut 2000 mil, and again, I'm going to use it in the demonstration for cutting apart and show you how the machine works with the Compact Series. But basically, I'd just like you to know that whether you have a tabletop lathe or a gantry mill, router, plasma cutter, laser cutter, or even you just need lab automation that needs an axis going back and forth, or even multiple axes moving back and forth, the FlashCut controller has full interpolated 5-axis motion, as well as basically if your machine is running any of these motors, the Compact Series is a good machine for you. I'm going to talk to you a little bit about some of the accessories that we have. First, we've got the control pendant. It's a 38 function control pendant, but it is 2 layers, so you don't have to mess with 38 different buttons. This is fully customizable through the software. You can choose which button means what type of command and so on and so forth. Basically what this will allow you to do is move about your machine, make sure your part's cutting correctly, make sure there's no errors, while you still maintain control over the software. So through this you can jog your motors, you can home your machine, you can even run a G-code program directly from the control pendant. Next we have the dual channel relay box. This is basically for use with different accessories that may need power. It has 2 90 to 240 volt AC power outputs, as well as 2 dry contact relay outputs. And this can be controlled again directly through the software, so I don't have to mess with, for example, I have my spindle plugged into here. I don't have to mess with turning the spindle on, or if I had a coolant pump or vacuum or anything like that, I wouldn't have to worry about turning those on individually. I could just turn it on directly from the software, and I'll show you a little bit about that a little bit later. Another one of the accessories I have is a limit switch kit. I already have that pre-installed on the 2000 mil, and this again is for demonstration purposes. What that's good for is machine homing, so that your machine has some sort of reference point, so that if you need repeatability in your parts, it's pretty easy to maintain. As well as travel limiting. It's kind of a safety feature, so that if your machine is about to over travel for any reason, the switches, if it's tripped, will just turn off the power to the motors and your machine will stop dead right where it is. Another accessories that we have are the rotary tables. We offer 4th and 5th axis rotary tables. As I already said, we have full interpolated 5-axis motion with the FlashCut controllers. And so this, basically if you have any need for very intricate parts or anything from 4 to 5-axis motion that you need, FlashCut has that ability. I don't have it installed on the 2000 mil because for the demonstration I'm just going to be cutting a simple part. But if you are cutting intricate parts, we do have those available. Finally, for the Compact Series, we have an expansion board that offers pulse width modulation as well as some analog outputs. Alright, so now that I've told you a little bit about it, let's get your machine up and running. First thing I want to mention, obviously you have to have the software installed on the computer before you do any of this. Basically, if you don't have that installed, the computer's not going to recognize the USB drivers from the controller, and of course without the software you're not going to be able to run the software, which is kind of an obvious thing. But now I'll show you how to plug in all your cables. Basically, with the FlashCut systems, we like it to be plug and play. Basically, you get your machine, put your motors on your machine, you get your controller, put your motors on your machine, plug it into the back of the box, and you're ready to run your machine. this can be up and running within a couple of minutes, and I'll show you that right now. First thing I'm going to plug in is the motor cables. I want to take a second to make sure you know this, that when you're plugging in anything to the box, it's important that the power's off. It doesn't necessarily mean that the power has to be unplugged, but as a good safety precaution, I always unplug my controller before I plug anything in or take anything out. Now I start plugging in the motors. So you can see here I have little labels on my motors. For example, this one says Axis 1. This is good. It's a good kind of habit to get into, of just immediately labeling your cables when you first get them, because well, you probably can't see, but under the table I've got a lot of wires and whatnot, and it kind of gets a little bit confusing, a little bit tangled. So if you label your cables before you put anything on your machine, it's going to make it a lot easier to set up your machine and get it running. So I have Axis 1. I'm just going to plug that into the back of the box here with Axis 1. This is my first drive. And I have Axis 2 right here. Plug that into Axis 2. And then, of course, Axis 3 plugs into Axis 3. Now, normally, Axis 1 would correspond to the X-axis, Axis 2 to the Y, Axis 3 to the Z. But really, if you have any needs that that needs to be switched, you can do that through the software. We just recommend that Axis 1 would be X-axis. That's just kind of the normal configuration. But again, you can set it up however you'd like. Next thing I'm going to plug in is the limit switch kit. This plugs into the input slot on the back of the box. And as you may be able to see, it might be hard with the camera angle, but there are a few open spaces in the limit switch plug. This is basically for if you have any other accessories that you want to add into the controller. You can do that here. And it's the same actually with the output, the dual channel relay box. Plug that into the output line. And again, there's a lot of open spots there for if you have other accessories that you want to work with. We actually do offer the ability to use 4 of our dual channel relay boxes, which would give you up to 8 outputs, 890 to 240 AC outputs. So if you have other accessories that you need to use, that's easily available with our controller. Next thing I'm going to plug in is the USB cable. It's a high-speed USB connection, and that just plugs in right to the USB slot. And then I'll make sure that's plugged into the computer properly. And then the last thing I plug in, as I said earlier, is the power. Just as a safety precaution, I'd like to keep the power out while I plug anything in or take anything out. Now that I have everything plugged in, I just plug it right into the power jack and just screw that on for a little bit of strain relief. Now what you'll see here, when I turn the controller on, you'll see a little light sequence. All the lights will flash on, and then from 1, 2, 3, 4, 5, those lights will come on individually right after each other. The yellow light here is the USB light. It basically indicates that the USB is connected properly and is working. The little light sequence that I talked about actually ensures that the firmware on the controller is working properly as well. And then finally, the power LED just lets you know that the power is on to the controller. So now that I have that all set up, I'm going to go ahead and connect my controller to the computer. So I'll just turn it on. And you can hear the sound, the ding, if you will. That's just the USB driver working. I'm going to open the software, and it's going to prompt me if I want to connect or not connect. I do have my controller all connected and ready, so I'm just going to click connect. Now it tells me to read through all the safety instructions. This is an important step. We want to make sure that when you're machining you are safe, so please read through and follow all the safety instructions. For example, if I'm going to be cutting a part soon, I should put on my goggles. Then I'll hit agree. Then you can see there's a green bar here that says connected, and that's your indicator that you are connected. Your machine is live. If you wanted to jog your motors or do any of that kind of things, you certainly can at this point. Before I do that though, I'm going to run the configuration wizard. It's basically a little wizard that we have set up for people who just get their machines, who just want a quick and easy way to set up their machine properly. And I'll show you how to get to that. You can go to File, New Setup. Basically what the wizard will do will ask you some higher level questions and do the lower level calculations for you that you don't necessarily need to worry about. It'll ask you questions like what type of machine you have, what type of dry box, and if you have any different accessories that are installed as well. So I have a FlashCut CNC machine tool. I accidentally pressed next twice. I also have the FlashCut 2000 milling system. And then my driver box is the 2.5 amp compact microstepping drive box. I did purchase a limit switch kit, as I showed you. I have that installed already. I do have a spindle relay box. I don't have a rotary table, but again, we do offer those as accessories. I just have no need for one with the part that I'm cutting. And then I do have a control pendant as well. Next step is to make sure your file location is in the proper place. And this is important, so if you lose your file or FlashCut has some issue with reopening your setup file, you can just go to the file path and open your setup file from there. And then it just asks you to confirm everything's correct, so I'll hit finish. One thing I want to touch on is the ability to customize the software. If you go to the configuration screen, you can customize any of the different settings that are in the screen. For example, if you want to change the feed rate ramping, you go to Machine, Feed Rate Ramping. You can see all the feed rates associated with machine movement. To ensure that the machine moves exactly the distance that the software dictates, just go to Drive Parameters. Here you can edit the drive mechanism and parameters to properly calibrate your machine. The software can account for various types of machines, such as rack and pinion, belted, or in this case, the lead screw drive mechanics. Okay, so now I'm connected, everything's ready to be run with my machine. The next thing I want to do is make sure that it is indeed running. The first thing I'm going to do is jog my motors. So I'll go to the jog tab. I'll just move my motors there. So the x-axis is working. Y-axis as well is working. And the z-axis is also working. Perfect. Next thing I'm going to show you is the spindle controller. So as I mentioned before with the accessories that I have, you can control the power to some of your accessories directly through the software. So I have a little tab right here that says spindle off. If I click that, it'll turn the spindle right on. Of course, it'll ask me to make sure that everything's safe, that it's okay to proceed. I'll hit yes, and the spindle comes on. This is great for you can set that in your G-code so that if you're moving, you can turn your spindle on at a specific point. Next thing I'll show you is when that output is on, there's a green LED indicator light that's also on. When I turn it off, that LED goes off as well as the spindle goes off. Next thing I'll show you is the control pendant in action. Again, I don't have any of the different stickers on there to show me which way it is, but I'm pretty familiar with it, so I know which button does what. So I'll just show you here how it moves. So I'll just press a button and it's going to move my axes. I can move the Y, positive, Z, negative, whatever it is. You can also seek home with the control pendant or run a G-code program or anything like that. Okay, the next thing I'm going to show you is how to home your device. And again, I mentioned this earlier with the limit switch kits. It's important to home your device because that way not only can you have repeatability in your parts, but it also, with the program, it'll be able to have a machine limit. It kind of has a machine envelope that will make sure that your machine can't travel over a certain distance if, for example, if one axis you don't have a limit switch installed for whatever reason. And the nice thing about the homing is if, again, for any reason you can't home a specific axis, so if, say, example, my Y axis, something was wrong and I couldn't home that axis because something was blocking the switch or something like that, I can individually home my axes. I don't have any issues right now with homing, so I'm just going to seek home with all three axes. So I'll just click seek home here. Now it's moving the Z first, and you can configure which axis it homes first through the software. Clicks the switch, comes back down a little bit. Then we have the homing there, the x-axis. Now the y-axis is homing. Okay, great. And now you might be able to see in my software I have a blue box that came up. That's my machine envelope, so I can't go beyond that at all. The program won't let me. Okay, now that I have everything homed and all that, I'd kind of like to cut apart. I don't know about you, but that's kind of where I'm at. So basically what I'd like to do now is load my G-code. So I'll just go to File, Open G-code, and I'm going to cut flash bolt 1. Now what it's telling me is that because of the machine envelope, this part is not going to be cut. Basically the reason that it's telling me this is because in the G-code it has the Z-axis moving up about 1/2 inch, whereas I can't move up at all because it's at the limit of its travel. That's okay right now because I know that I'm not going to be cutting apart this high. I will be moving down and re-zeroing my program coordinates. So what I'm going to do then is I'm going to jog kind of to a point where I would like to start my G code. So the first thing I'll do, I'll move my X over. I'm going to move my Y up a little bit. And then obviously I need to move my Z a little bit down there. And I'm going to show you how to zero your program coordinates. This will help you so that you have a starting point with your G code, and this will get that all set up for you. So you're kind of just in this instance you're arbitrarily choosing a point with the G code that I'm running. It's not quite as important where exactly it is on the piece of metal that I'm cutting. Alright. So I'd say that looks about good. Now all I do is zero my program coordinates. And now I'll show you how to actually zero the Z. Good way to zero it, just use a piece of paper and you kind of want to rub the piece of paper back and forth until the bit is on, kind of clamps the paper down on top of what you're cutting. And that's a good indication that you are basically at the 0 point. So I'm pretty close, so I'm just going to move down slowly here. So I'm moving by hundredths right now, because I want to go slow. So the last thing I want to do is put my tool right into the metal and break the tool or break the enclosure. So as you can see, I have it pretty nicely zeroed. It ripped the paper right there. Now as I said before, you're basically at the 0 point when you zero on top of the paper, but in reality you are about 3 thousandths away from 0 because the paper is about 3 thousandths thick. So if your part needs that specific precision, you can actually set your Z height so that it takes that into account. Just go to Program, Set, Enter, and right there you can enter in what the Z height actually is based on where the paper was, and it'll take that into account when it runs the program. For my purposes, I don't need that because I am not cutting a part that's that intricate. So basically now I'm ready to go. All I do is I will zero my Z so that it knows, and now I'm ready to cut my part. So the first thing I'm going to do, I'm going to turn the spindle on, and then I'm going to go, well, I'll show you how to get to the G code first before I turn the spindle on so you can hear. I go to the G code tab, all I'm going to do is press start. As you can see, there's faster, slower buttons here if you want it to go faster or slower. There's feed hold if for any reason you need to stop your program while it's running, you can click that, or you can click any of the buttons on your keyboard. And there's also a jump to line. If you want to start at a specific point in the G code, you can always jump to the line and go that way. Now I'll turn my spindle on and I'll cut the part. As you can see, while the part is cutting, we have a real-time view of the tool path that's updated continuously in one of the viewports. We also have the DRO that updates continuously of the numerical value of where the axis is along the tool path. And then finally, the G code actually goes line by line in real time to show you what part of the G code it's actually in. And there's our part. I hope you found this guide to be beneficial and were able to get your new compact series up and running. Our engineers are available to provide full technical support as well as in-depth solutions to each customer's unique application. If you have any questions or concerns about the controller or its use, please visit our website, call, or email us at any time. Be safe and happy machining!